Hello, good morning, students. Today, I would like to discuss the topic Newton's laws of motion. Actually, this topic is very useful for competitive point of view, which comes in I think ninth class, and then NEET point of view, very important topic here. To prepare for the competitive exams, it is very important topic. Among them, first of all, Newton's laws of motion. What is Newton's first law? Here, Newton's first law statement will be like this. First law. Every body continues in state of rest or of uniform motion in a straight line unless it is compelled by any external force to change that state. This is the statement of Newton's first law. I would like to repeat once again. Every body means object, whatever it may be. Every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by any external force to change its state. That is a statement of Newton's first law. So how can you explain this Newton's first law? See here, one body is there. Say for example, I am standing here, or I am moving in the straight line. That means I am standing here means I am in the rest position. But I am walking on the floor in a straight line. That means I am in the motion. Say I am in the rest position. Up to what time I am in the rest position? Unless some external force acting on me. Say for example, I am thirsty. I would like to drink a glass of water. Then I will go there. That means external force acting on me. Or you can say simply, the best examples. If a chair is there, the chair is in the rest only. Rest only. Unless up to what time it will be in the rest position. If you apply some force on it, then it will move. That is external force if you apply to change its state. Say for example, if a fan is rotating. If it is rotating until some external force acting on the body, that means if you switch off it, then automatically it will stop. So that means if a body is in the rest only. If it is in the uniform motion only, unless some external force applied on it to change its position or state. That can be explained by the Newton's first law. Here, some more, he explained the concept of inertia also. So how can you measure the inertia? For measuring the inertia, mass is the measure of inertia, we can say. So for example, best example, if a bus is there, if bus is full of passengers, that means fully loaded bus, that means more mass, that means it will have more inertia, that means it will move smoothly on a rough road. So for example, if a bus having one conductor, driver and some 2-3 passengers in a bus, it is moving on the rough road, what happened? Mass is less, that's why up and downs will be there. Like this, up and downs will be there. That means we can measure the inertia by using the concept of mass. Now, basing on this, inertia can be explained in 3 types. One is inertia of rest, inertia of motion, inertia of direction. So, how can you explain this? First one is inertia of rest. So, same example I will use. Say for example, if a bus is there, So let us assume it will looking like a bus, let us say. So here is the driver seat, okay, steering, whatever, okay. Bus is there. Now inside the bus, now the bus is in a rest position. Initially, the bus is in the rest position. Now a person in a bus holding the rod, above rod, and standing on the floor like this, holding the rod and standing on the floor. That means initially the position of the bus is in the rest only. If the bus suddenly starts, what happened? He will feel, if he holding like this, if bus suddenly stops means, start means initially the position is rest only. If bus suddenly starts, he fall backwards. That is due to the inertia of rest. Why? Because the floor with the legs are in the rest position. This is the best example for the inertia of rest. That means the person in the bus standing on floor, if it starts suddenly, this is important, he fall backwards. This is the best example for the inertia of rest. Another one is inertia of motion. Inertia of motion, we can say. So same example I'm using here. Same bus, same person standing on the floor of the bus. If the bus is in motion, moving bus, if it stands like this, if bus suddenly stops, sudden brake is there, then the person in the bus fall forwards. Okay, now that is due to the inertia of motion. Why? Because here you are considering initial position of the bus is in motion. That is important point. Previously, initial position is in the rest. Now the bus is in motion. So we can say that simply the person in the bus, in the moving bus, okay, if bus suddenly stops, he fall backwards. This is due to the inertia of motion. Though these two are the best examples, some other is also there. That is inertia of direction. So I will explain this simply. Say if the moving bus is there, if a bus take a curved path like this, curved path, same person holding here, the bus is moving in the curved path, then he fall opposite to the direction of the curved path. That is the best example for the inertia of direction. Direction will be in the opposite direction. So this is about the Newton's first law, which gives the concept of inertia. We can say mass is the measure of inertia. So this is about the Newton's first law. Next will be the Newton's second law. See, second law. Newton's second law. How will you explain the Newton's second law? Actually, this law gives the definition of force. We can say that simply, Newton's second law means a rate of change of momentum. Rate of change of momentum is directly proportional to rate of change of momentum is directly proportional to external force applied on it. The body will move in the direction of force. Simply you can extend. Simple definition is like this. Rate of change of momentum is directly proportional to external force applied on it. On it means on the body. So, how can you explain this Newton's second law? Very, very important Newton's second law. Say for this, I am considering a body is here whose mass is small m, you can say. It will moving with initial velocity u. After some time, if you applying some force on the body, after time t seconds, the body mass does not change, but velocity obviously changes to v by applying some external force on the body. Okay. Now, if a body is there, it will having mass and initial velocity. So, mass, initial velocity. As we know that the product of mass and initial velocity is nothing but the momentum. So, we can say it will have initial momentum. What is initial momentum? Initial momentum. Momentum can be represented by the symbol of pi. You can say this is mu. After time t seconds, what is final momentum? Final momentum, that is pf, we can say mv, because product of mass and velocity is nothing but the momentum. Some more, what is change in momentum? Change in momentum. So for the small changes, you can use the symbol delta p or dp, whatever it may be. We can use simply dp. dp is equal to final momentum minus initial momentum. Okay. Now, this is the change in momentum. So, according to the Newton's second law, what we know? Rate of change of momentum is directly proportional to the force. Rate in the case by time. Rate, whenever the rate word comes, you can use by time, divided by time. So, you can say directly, force can be represented with a symbol of capital F. Force F is proportional to, what is the change in momentum. Change in momentum means a rate of change in momentum. You can say dp by dt. dt means the small time interval. So this is the formula for the force. Now to remove the proportionality constant, you can use the formula F is equal to some k into dp by dt, where k you can call as proportionality constant. So generally, if you take the value of k is 1, then you can say simply F is equal to dp by dt. Some again, I would like to derive some more. What do you mean by dp? dp in the sense pf minus pi. As usual, pf minus pi by dt. What is pf? mv. What is pi? mu. Substitute here. mv minus mu by time interval t, you can say 0 to t means you can take t minus 0 tr. Now take out the m as the common. What you will get? V minus u by t. But I know that V minus u by t is nothing but, very good, acceleration. So from the definition of acceleration, acceleration A is equal to rate of change of velocity is nothing but acceleration. Change in velocity means rate means v by t. So A is equal to v minus u by t. Now in place of v minus u by t, I can substitute A. Then you will get F is equal to ma. This is the formula for the force. So this is very, very important formula. It will be helpful to you in nearly all topics. Wherever the physics is there, then force is there. That is the formula. F is equal to ma. Now, try to remember the units of force. So as we know that the first topic, I will explain you about the units and dimensions. So we can say simply units. Say mass, kg, acceleration, velocity by time, velocity, meter per second, by time, second, meter by second, second, that is meter per second square. So kg meter per second square. This is the unit. So another unit, who would give the definition of force? Newton. That's why another unit is, that is SI unit, you can say. SI unit is Newton. Simple. That is, symbol is capital M. Newton. So what about the CGS units? So CGS units is nothing but dynes. As we know that 1 Newton is equal to 10 over 5 dynes. So this is about the force. 1 Newton is equal to 10 power 5 dynes. So this is about the Newton's second law. Now what are the applications of this Newton's second law? Oh, applications. Now, the applications of the Newton's second law is, number one is, here we know the formula, force F is equal to mv minus mu by t, isn't it? Now from this formula, I will get the small definition, that is impulse. Impulse represents the symbol of I. So how can we define the impulse? So do the cross multiplication here. What do we get? F into T is equal to mv minus mu, which is nothing but impulse I. How can you define this? Simple manner. The product of force and time, or this is final momentum minus initial momentum, that is change in momentum. Simply you can write, or change in momentum is called impulse. Represented by symbol of I. So what are the units for this? So you can write I is equal to F into T or mv minus mu. What are the units? As usual, force, already I know that unit is Newton. Newton. And time, as you know, second. That is, Newton second is 1 unit. Or another unit also there. That is change in momentum. Change in momentum is nothing but momentum only, na? So mass, that is kg. Velocity, as you know that velocity is nothing but meter per second. This is the another unit of impulse. Now, what are the applications, examples of impulse? What are the examples? So many examples are there. One of them is number one. Say, everybody plays cricket, I think so. So while catching the cricket ball, say if you like this, if you throw the ball, if you catching the cricket ball, what they will do? While fielder catching the cricket ball, what he will do? He pulls hands backwards. Why? Because if you won't pull the hands backwards, the ball will come with a large force. It will strike the hand, automatically your hands will be damaged. Some reddish color will come, or it will be harmful, or not harmful, it will be strike on your hand. So that you feel very, what do you say? Okay, like that. Now, to avoid such type of large force, what you have to do? Actually, you have to catch here at this point. You are pulling to the down, means from there to here, I am increasing the time. As we know that force and time are inversely proportional. Side by side indicates inversely proportional. Inversely in the sense, if force is more, time is less. If force is less, time is more. That means here I am pulling the ball downwards. That means I am increasing the time of action. I am increasing the time of action. If the time of action is increases, automatically what happens? Force will be reduced. That means decreased. That's why while catching a cricket ball, the fielder pulls his hands backwards. That's the best example. So we can say while catching a cricket ball, the fielder pulls his hands backwards because to reduce the force, that you can say impulsive force, to reduce the impulsive force, have to increase time of action. This will be kept in the quotations. So if they ask related to this impulse applications, in every application you can use this one, 90%. To reduce the impulsive force, have to increase the time of action. This is one example. Some another example is also there. So shock absorbers. Say for example, generally everybody ride on the bike. Just below the seat of the bike or front of the handle below, two springs will be provided, which we can say that is a shock absorbers. So when the vehicle is moving speedily, then in front of a depth is there. So if the you can see the advertisement in the TV, I think so. Some Hero Honda vehicle advertisement. The girl holding the pots one by one above the top, and the shock absorbers are very smooth so that it doesn't fall down. That is the best example you can see. So at that moment, so for the in that case, what happened over there? So the shock absorbers are there. In front of them, a depth dip, what do you say? A dove can come. That means if the body is moving, if the vehicle is moving like this, then if the shock absorbers is not there, then what happened? Automatically, the bike will suddenly stops and some riding person may fall down. If the shock absorbers are there means, then it will go large force. That means large force applied to reduce the force. What happened? You have to increase the time of action. That means it will go smoothly like this and like this. That means here time gradually increases so that force will be reduced. So that is also the best example for the impulse. So this is about the impulse and the examples, which is the application of the Newton's second law. So this is about the Newton's second. Next will be the Newton's third law. What is Newton's third law? See, this is very important law. Newton's third law. How can you give the definition? Simple definition. For every action, there is an equal and opposite reaction. This is important. For every action, there is an equal and opposite reaction. That's the statement of the Newton's third law. So, but action reaction will be acting on different bodies, not on the same body, different body. That is important. So, action and reaction acting on different bodies. This is important, not same body, different bodies. This is the statement of Newton's third law. For every action, there is an equal and opposite reaction. So many examples you can say. If anybody slaps on you, slaps you, then what happened? There is an action. The pain is reaction, simply we can say. So some the best example for this is our textbook examples. So example number 1, upward thrust on a rocket. This is the best example. So as we know that F is equal to ma, that's the formula, or you can say F is equal to m into acceleration, means rate of change of velocity, or you can say simply dv by dt. I can write like this also. No, F is equal to m. I can write like this. Say for example, if you take a rocket is there, okay. Yeah, okay. This is a 5. So when the rocket is actually the design of rocket will be made up of with 4 parts. So first part, when it is launching, first part will be exploded. So the action, it will move in the upward direction, that is reaction. Some more, and then it will go to certain height, and then second part will be exploded, that means burns. Due to that action, it will move some more distance, that is reaction. Here you can observe that the parts are moving more, that means first part, second part, third part is moving. Exploding means what you can say is mass will be decreasing here, that means velocity will be same, velocity is constant but mass will be varying. That means you can say that here according to this formula mass is constant, but according to this upward thrust on a rocket, action will be in the downward direction, reaction will be in the upward direction. This is action, this is reaction, which are in the opposite directions, equal and opposite direction. So you can say the formula F is equal to velocity is constant but mass is variable here. That means you can use the formula m is equal to v into dm by dt. So these are the examples for the Newton's third law. This is about the first law, second law and third law. So we can do some problems related to this, no problem. Okay. So it will be continued in the next class. Thanks for watching.